Hello students, my name is Waseem Hassan and I am supposed to teach you mathematics class 10th. Today's topic is surface, areas and volume. Before discussing this thing, we should know what basically the volume is and area is. But discussing that, I should discuss with you what is a 2D system, what is a 3D system, and in fact, what is a 1D, 2D and 3D. And today we know about the fourth dimensional, we know about the fifth dimension, we know about the sixth D also. But the question arises here, so what is dimension? Let us discuss what is dimension. We will go into it deeply. We all know the coordinate geometry, coordinate system. And we also know that the father of coordinate geometry was René Descartes. And he is a person who gave us the concept of 3D system. What he did, he make a planar geometry concept like this. This is board, it is a 2D system. I can't draw this at an angle of 90 here. So to represent this 90 degree, this is a z-axis, I will draw like this fashion. But this angle is not 120, it is 90 degree. At this angle, it's also 90. And this angle is also 90 degree. So the question is, why we call this axis as z-axis and this y-axis and this x-axis? The answer is, it is just a convention. It's just a convention. This is x-axis, this is y-axis, and this is not z, this is z-axis. And the second name of this x-axis is abscissa. It's abscissa. And y, this we know as ordinate. And z, this we know as an applicate. This is abscissa, this is applicate, and this is ordinate. So we can conclude here, so whatever we have in the space, nothing in the space is 1D, nothing in the space is 2D, every object, it is a 3D object. It is a 3D object. I will take an example. I have this plane. This is a plane. So we generally say, sir, this is a 2D figure. But I will tell you, we are wrong. This is not a 2D. This is basically a 3D. So the question is, how can we defend? How can I defend that this is 3D? This is one axis, this is x-axis. This is second axis, this is z-axis. But what about this is y-axis. What about the z-axis? It's thickness. It's this thickness. If we make this thickness equivalent to 0, that means, sir, you will say that we have 2D system. But think, if we make the z-axis equivalent to 0, this thing will not exist. It is simple. If you make the z equivalent to 0, this will vanish. कोई चीज होगी ही नहीं. That means जब z में 0 बनाऊंगा, yeah, I can say like this. If I make x equivalent to 0, y equivalent to 0 और z equivalent to 0, there is nothing like that. कोई चीज है ही नहीं स्पेस में. अगर मैं ये नॉन जीरो बना रहा हूँ, ये नॉन जीरो बना और z को 0 बना रहा हूँ, कोई भी चीज है ही नहीं. So what is the thing? Thing is that, sir, every object, every physical object, it is a 3D system. Right? So discussing the areas and volume, we should discuss how we can say 3D system. How can we discuss the 3D systems? Let's go into the 3D system now. 3D system are started by the solids. Solids are 3D objects. Solids are basically of two types. One is known as polyhedra. Second is known as solids of revolution. Polyhedra. The question is, what is a polyhedra? Polyhedra are those 3D objects which have the corners and which have the edge. Which have the corners and which have the edge. The polyhedra are basically up to the class 10th level. I'm teaching the class 10th, so I will just teach here the up to level of 10th class. Polyhedra are of two types here. One is known as prisms and second is known as pyramids. What about the solids of revolution? Solids of revolution are three types. One is known as cone, second is known as cylinder, and third is known as sphere. Right? So let us discuss what is a prism. This object, this is a prism. What is the shape? This is a hexagonal shape. But if I do one thing, if I compress this object like this, I am compressing it, I am making this edge not zero but negligible as compared to what? Its other two dimensions. It will look like this. This is hexagon. This is hexagon. If I take this object and I do one thing, I will extrude it. Extrude command is in AutoCAD. Extrude means you are extruding it, right? But you are keeping the back plane at a fixed position. That means you are increasing its length. But what will happen? The face, the front object will look like the same. It's a hexagon and the back is again a hexagon and its height gets increased. That means its length gets increased and it will look like this. This we know as a prisms because it has a corner here, it has a corner here, it has a 6 corners and edges. Am I clear about this? This is known as a hexagonal prism. That means prisms are of various types. The basic prism, it is a triangular prism. Second, it is a square prism. Third, it is a pentagonal prism. Right? Then we have hexagonal prism. So it depends upon the number of sides of the base. You have the triangle, it's known as a triangular prism. You have the square, its square is here. This is known as a square prism because base is square. Then we have the pentagonal prism. Pentagon is here. The base is here, it's a pentagonal prism, then hexagonal prism, then we can have the heptagonal prism, then we can have the octagonal prism, then we can have what? Nonagonal, and then we have a decagonal prism. Clear? Now let's come to the pyramid. What is pyramid? Same here. Pyramids are of same types. It's a triangular, not prism, it will be a triangular pyramid, right? Then we have the square pyramid, then we have the pentagonal pyramid, then we have hexagonal, then we have heptagonal, then we have octagonal, then nonagonal, then deca, and so on. Clear? Let us discuss now, sir, what is prism? Please be here. This is a what? This is a triangle. And we all know its center will lie here, right? I will do one thing. I will stand an axis here, which is at an angle of 90 degree with the base. 90 degree with the base. Its height. Let we take height equal to 30 centimeter or 20 centimeter. It's a supposition, right? And then what we will do, we will make in one line which will connect this vertex with the top, like this. And second, this point and this point will be connected like this. That means the area of this surface will again be a triangle. And same from this side and same from this side. That means this will look like this. Base is a triangle, sides are one triangle, second triangle, and third triangle. And top there is no other triangle. There is a point which we know as what? Apex. This is known as the apex point. Clear? What is the difference then between prism and pyramid? Only one difference, and that is a basic difference. The difference is if I extrude it like this, the top surface will be triangle, the bottom surface will be triangle, and there will be 3 parallelograms. Here will be rectangle, here will be rectangle, here will be rectangle, and rectangle is what? It's a parallelogram. Now, what is a pyramid? Pyramid is you have to make a center of the surface and put it here axis and join all the lines with the apex point, and you get all surfaces, not parallelograms. It will definitely be a triangles. This is a basic difference between the prisms and pyramids. Right? Let us move on to the now next type of solids, which we know as to be solids of revolution. So question is, sir, why these solids are known as solids of revolution? There is a concept in it. Why these are known as solids of revolution? Suppose I have this triangle. I will make this point, I will make it a fix. And then I will rotate it like this. It will traverse a trajectory. When it will traverse a trajectory, it will make us some 3D object. It will be a hypothetical 3D object with a sum of radius and with some height. So what is the basic 2D surface which we rotate to get the cone? It is a right angle triangle. It's a right angle triangle. When you have this object like this, you make this side as a fix. This is a convention to show that the side is fixed. When you make this fix, I will name it here A, B and C. I will make AB as a fix. Then I will rotate this BC. Let it be R. I will rotate it. When it will get rotated, so definitely it will traverse base. And base will be a what? It will be a circle. And this slant height will traverse like this. And it will traverse a curved surface area of the cone. I will make a 3D object on a board. And board is 2D object. I will make it like this. Right? So this height from this point, this is known as the H, height of the cone. And from this point to this point, this is known as the R. This is the R of radius. Right? So we discussed it how the cone is what? Made from the 2D surface. Now let us discuss about the cylinder. How the cylinder is made. This is square. Right? If I make this side fix it and this side I will rotate like this, it will get rotate like this. The trajectory will it make, this will be a what? It will be a circle, base circle, and it's the same line here. It will be a top circle and a curved surface aega, which is known as a curved surface area of cylinder. So how many surfaces? Top surface, this is a what? Area of circle. Bottom surface, another circle, and curved surface. That means I am creating cylinder. I am creating a cylinder by a what? A rectangle or a square. Am I clear about it? Now let's go for the sphere. This is a circle, right? If I make a diameter like this is the diameter, I will make it what? Fix. Then I will rotate not 360 degree. I will rotate just 180 degree. That's like this. Make it is a first position. I am trajectorying it. I am trajectorying. I am starting here. I am starting here. I am just rotating. This is the first point. I am rotating, and this is a point which meets that point where from I started. So it is conversing a trajectory. This trajectory is nothing. It's creating a structure. It's creating a 3D like a football, a 3D like a cricket ball. That's a sphere. So I am creating a sphere from a circle. Am I clear about it? Now we will discuss what we have to teach in this chapter. This was the basics where from the cube has come. This is the basic where from the cone has come, where from the sphere has come. Right? Let us discuss now our exercise number 1. In this chapter, we have to discuss about the fifth shapes. One shape is it's a cube. But do you know the cube is basically a prism? Cube is just a name, but basically it is a prism. But sir, which type of prism? It is a square prism. It's a square prism. Now the question is, then what is a cuboid? Answer is, cuboid is again a square prism. And there's a little difference between the cuboid and the cube. But cube and cuboid are both square prisms. This is a square prism. It has a length more than the length of the side. This is known as a cuboid. But precisely the basic name, the family name is prism. Which type of prism? Square prism. But which type of solid? Polyhedra. Polyhedra, it's a solid. It's a 3D. So 3D, polyhedra, square prism. Perfect. Which square prism? It is a cuboid and cube. If I make one thing, I decrease the length, height. I make the height equivalent to the side. The height will be equivalent to this side, will be equivalent to this side. The cuboid will get changed into the cube. But still, it will remain as a square prism. And when we talk about the cuboid, it is still what? A square prism. Now, let's talk about the exercise. It's a 13.1 exercise, then we have 13.2 exercise, then we have 13.3 and 13.4. I will give you a whole sense of the chapter. What we have to discuss from the beginning to final point in this chapter. First exercise is based on only and only areas. It's only on areas, right? And the second exercise is totally based on the volumes. But the third exercise is based on the conversion. It's based on the conversion, right? If we change the shape, which thing will remain constant and what will happen to the dimensions? The length will get increased, the diameter get decreased, but total capacity, total volume will remain constant. And 13.4 exercise is based on the whole sum of the questions. The question from 13.1, 13.2 and 13.3. This is the whole a look at the surface areas and volumes. Now let us take the exercise first. That is a 13.1. Exercise first. What the question says? Question is this. Question says 2 cubes, each of volume 64 centimeter cube. 2 cubes are there. This is a 1 cube. This is cube, right? It has a volume equivalent to what? 64 centimeter cube. We can say, since volume of a cube is equal to 64 centimeter cube. Let us say the side is equivalent to x. Simply, this side will be also x centimeter. This will be x centimeter and the height will definitely be equivalent to x centimeter. Then I will read the question furthermore. 64 centimeter cube are joining end to end. What does that mean, end to end? Imagine this thing. Take it, this is a cuboid, right? I'll just break up here. Equivalent to this height is equivalent to this and this is equivalent to this. If we can imagine the thing, if I just cut it in between, it will one cube will be in my left hand and second cube will be in my right hand. Now join them. When I will join 2 cubes, it will become a cuboid, not a cube. It's a simple thing. It will become a what? Cube. But the question is, sir, does every dimension change here? No. Only one dimension changes. Which dimension? This dimension. This dimension, this length. If this is a x and this is a x, it will become 2x. But this will remain as a x and this will remain as a x. Hope I am clear to all of you. Right? What we'll write here? Let side of cube be equal to x centimeter, which I write. Right? Then we know that, what we know? Volume of cube is equal to side cube. That's a x cube cubic centimeter. That's a centimeter cube. Cubic centimeter. Here we can say cubic units. Volume of cube. What is the volume of cube? It is 64. And this is x cube. Or I can write like this. X cube is equal to 64. We know this, which implies x is a cube root of 64. Clear? But we also know this, 64 is a cube root of, it's a 4 cube. This is x cube and this cube root goes, x is equal to 4 centimeter. Right? So what we found, this x is equal to 4 centimeter. Now the question is not only saying calculate the side of the cube. What the question says? Question says find the surface area of the resulting cuboid. We have to find the what? Resulting area. That's the total surface area of the cuboid. So x is equivalent to 4 centimeter. So remember another formula. Total surface area of cuboid is equal twice. This is a cuboid here. I will make a cuboid here. Right? Right? This is a cuboid here, but this is a cube because every side is equal. Here you have the what? X is equal to 4. This is also 4, but this will not remain as a what? 4. This will become 4 plus 4 because two cubes are joined together. It will become 8. Am I clear? This is a cube. What is the total surface area of this? It's equal to twice length plus breadth plus height plus length. Am I clear about this? Length, breadth plus breadth, height plus height, length. But the question you will definitely raise, sir, how? This is cuboid. Clear? Please. This is length. This is height. This is a plane, a rectangle plane. We know the area of rectangle. It's a length into height. So this area is length into height. But where from the two come? This area, back and page same area, the area of this plane and the area of this plane will be the same. That is a what? Length breadth and length breadth. I can write it like this also. It's a length breadth plus length breadth. Then what? Breadth height. Where is breadth? Where is breadth? This is height, this is breadth. So this is the area of this side. And again the area of this side. This is again the twice. Breadth height plus breadth height. Then similarly, height and length. That is this. Clear? So again, it will be HL plus HL. And I can summarize it like this. So what we have to do now? Just put the value and get the answer. So we conclude that length is not 4, length is 8. So it is 8. What is the B? It will definitely be 4. Plus what's B? It is 4. Height it is 4. Plus height it is 4. But what is length? It is 8. 4 8 are 32. Plus 4 4 are 16. 4 are 32. Clear? So what is the sum? It's 80. I have done it already. Its calculation. It's 2 into 80. The answer is 160 centimeters square. What is this? This is a total surface area of cuboid. Which cuboid? That cuboid which I made from the two cubes joining end to end.